I'm Mateen.
And I'm Stephanie.
And we're going to talk to you about waves.
Just for our background, waves are created through the vibration of matter.
Hey Lily.
Hey Vishaal.
Why is the wave theory so important?
Wave theory is so important because without it, we wouldn't be able to explain how light and sound waves move throughout space.
Oh, I see. That's pretty cool.
Yeah.
The wave theory states that light and other radiation is transmitted by waves.
The wave theory helps scientists analyze different types of waves, such as
microwaves,
X-ray,
and normal waves.
whoa,
Woo! Just kidding.
In a simple diagram, the crest is the top of the wave, while the trough is the bottom of the wave.
Amplitude is from the midpoint to the top of the crest, or from the midpoint to the bottom of the trough. Wavelength is from crest to crest, or trough to trough.
Now we will be able to look at spherical waves. Spherical waves are families of circular waves that move out from the origin. The direction of travel is always perpendicular to the surface of the spheres.
In this picture, we can measure three things. First, for wavelength, we measure the distance between the crests, the white parts. We found the distance to be 0.12 meters. Then we can find the frequency by dividing 1 by how many waves occur in a second. This was 0.24 hertz. Then we can find the speed in which the wave moves by multiplying the wavelength times the wave frequency. 0.12 times 0.24, which equals 0.029 meters per second.
Plane waves are a series of linear waves that move in a parallel motion from the origin wave.
We can see the same three parts in the plane wave. The distance between the crests, the white parts, is the wavelength. This was 0.08 meters. The wave frequency is 1 divided by the number of waves in a second. This was 0.27 hertz. Then we can find the wave speed by multiplying the wavelength by the wave frequency. 0.08 times 0.27 is 0.022 meters per second.
This is a video of dual pin interference, when two spherical waves that superimpose to create a wave with greater or less amplitude.
This is double slit interference. Double slit interference occurs when two transverse waves combine to create a wave with greater or less amplitude.
This is a picture of constructive interference. Constructive interference is when two waves come together, form a larger wave, and split in opposite directions. This is destructive interference, which is when two waves of opposite displacement along the medium come together, cancel out, and then continue moving in the same direction.
The difference between the two interferences is that for dual pin interference it has spherical waves, while for double slit interference it has transverse waves.
Wave interference is present in real life. Concert hall walls are designed with acoustics in mind to interfere constructively with sound waves. But in an average room, the walls interfere destructively with the sound waves and produce a dull and lifeless sound.
Now we shall analyze wave reflection. Wave reflection is a change in direction that a wave experiences when it bounces off a barrier. In order to view this reflection, first we drew a line on a piece of paper and a line perpendicular to that line. We placed this paper under the ripple tank. Then we noted down the angle in which the waves hit the barrier and the angle in which the waves went after hitting the barrier. The distance in degrees between the entrance point and 90 degrees is known as the angle of incidence. The distance in degrees between 90 degrees and the angle which the waves bounce off is known as the angle of reflection. In a perfect experiment, these two would be the same. In our first trial, the angle of incidence was 44 degrees, and the angle of reflection was 43 degrees. In our second trial, the angle of incidence was 40 degrees, and the angle of reflection was 42 degrees. In our last trial, the angle of incidence was 50 degrees, and the angle of reflection was 54 degrees. The law of reflection states that the angle of incidence and the angle of reflection should be the same.
You see reflective light waves every day when you look in the mirror. This is an example of wave diffraction. Wave diffraction is the process in which a wave passes through a boundary. Once the wave has passed the boundary, it will spread out to fill the medium.
As the barrier gap increases, the wave spreads out more. This causes the process of diffraction to be faster. When the barrier gap decreases, the wave spreads out less and diffraction occurs slower.
The Doppler effect is the change in frequency of a wave when it's moving relative to you.
If someone ran by you while screaming, their voice would be higher while they're approaching, but lower while they leave. This is because those stationary waves are uniform. Moving waves have higher frequency in front than they do in the back.